Hey everyone, welcome back to the channel. In this video, we will discuss about how do you write unit test cases or integration test cases with the Terraform using the Terratest. So we'll use the Terratest technology to automate our infrastructure with unit test cases, which is written in Terraform with Azure subscription. So if you are finding difficulties to write unit test cases in Terraform, which is for the Azure, then this particular video will help you a lot to understand and simplify writing your test cases, understanding how do you write the test cases. I will highly recommend to watch the video till the end. If you do have any question, please do let me know in the comment section. Without getting further delay, let's begin the discussion. So as I mentioned, we are going to use the Terratest to write our unit test cases or our integration test cases in the Terraform. So let's try and understand something about the Terratest. So Terratest is a tool owned by the Grunt worker, which is the organization, which you can find it here on the website. So this particular tool, which is Terratest, it's been written in the Go language. So Go language is the behind the scene language which is being used to write all the test cases which has been supported. So Terratest, the name is sounds like it is basically given only for the support to the Terratest, but it's not like the support for the Terratest, but in fact they provide the automated support for many APIs such as the AWS, Google, GCP, Kubernetes, HTTP, Helm. So any kind of APIs or automation tools which you are using in your infrastructure support, then that is the Terratest is the technology which we can use to automate your infrastructure and write your test cases with the help of Terratest. So the overall principle remains same, but these are the listed APIs which are being supported. So don't get confused with the name Terratest, which sounds like it is starting with the it's only limited to the Terraform, but it's not the case. One more thing to point here, as I mentioned, Terratest is owned by the Terragrunt IO worker. So Terragrunt's main website is terragrunt.gruntio.worker, and you can find the detail that it has been basically created by the with the help of Go language. So as you can see here, they have mentioned that behind the scene it works on the Go. So you need to have a slight understanding about the Go language, how it works. Even though if you do not for this particular demonstration, I will try to give you some update about the Go language, at least the information which you needed to automate your infrastructure, which you might require to handle or manage your code with the Go while writing the test cases. Okay, with that, let's go ahead and start writing our very first test cases. We'll follow this particular documentation which has been given here so that you understand what I'm trying to do here. So first of all, I would like to open the Visual Studio Code. We'll create our Azure infrastructure in Terraform, and then we'll write the automation test cases with the Terratest. Let's begin now. So I have a Git repository created just now for this particular demonstration, and in this Git repository I have a module folder, as you can see here on the screen. In this module folder, basically we have created a Terraform modules, and these are the modules we would like to automate or write the unit test cases for. So now for this demonstration, I would like to create another module which is storage account, and then we will test the storage account module with the Terratest. Rule number 1 to write the Terratest cases or the test cases is simplified your automation code, which is instead of testing the entire infrastructure which contains hundreds of resources for your infrastructure, and instead of testing all of them together, you should always test the small pieces. So like in any language, when you write a unit test cases, you test the unit of functionality, which is a test of a particular method, and then you test another method, and then it covers the entire class, and then you generate the overall basically scope of test coverage. So similarly here with the Terraform, it is highly recommended that you focus on testing the individual modules rather than testing the whole infrastructure together. So that's the reason we are creating the Terraform modules here, and we are going to test the individual modules just to make sure that the module which we have written is working fine as we have expected. Because if that works fine, then we know that it will produce the right output when somebody is going to use the modules itself. With that, let's create a folder called the story account. So that's the story account module, which name says that it's going to create a story accounts, and then I'll create a main.tf and variables.tf files, which will hold the my variables and the story account implementation in the main.tf file. So let's say this is the story account resource block which we have in our infrastructure, and that will produce a new story account every time somebody will call this module. This is using some of the variables, as you can see here, and those variables are defined here on the variable. I haven't basically mentioned the details about the variable description and all. This is just not the focus of this particular discussion. So considering we have this story account, which is basically creating the resource itself here, and now with that we should be able to create a story account. So our Terraform code is ready to produce the outcome. Now the step number 2, we need to have a test block which will test this particular module. So let's say we need to have the provisioner or a block which will basically test this particular module and make sure that the module is working fine, even though if I'm going to run it manually, forget about the unit test cases. So what I'm going to do, it is highly recommend that you should create the directory here in the module itself. So we are going to call it as the provision infrastructure. So we are going to call it a provision, and then here within the provision we will add the run.tf, or you can call it anything, run.tf, main.tf, or execute.tf, whatever you want to call it. So basically this particular file, what we are going to do, we will call from this file, we are going to call this particular module, and we'll test the functionality of the story account from the Terraform execution. So this is going to be our provision or run.tf definition, where we are going to have some Terraform block to initialize or download our Azure provider exe, and then we'll configure the Azure RM backend in case if it needed to be a remote backend. It is highly recommended to have a remote backend. Then we will have a module. As you can see, we are using the module keyword, and we are calling it as core storage account module. And the source definition or the source location of this module is just the one level above. So this is the directory we are in right now. So it will go to the one level above, which is the story account directory, and within the story account directory we would like to invoke the main.tf or variable.tf file. And we know that this main.tf file expect these many variables to be passed on. So we need to have these variables values which we are going to pass, and once that particular module will be executed, it will return some outcome, and the outcome we are capturing it here as an output variable. So we have defined some variables as well. So simple, we are just testing the module, the story account module from the provisioner itself. This is the structure which has been suggested here in the quick start guide. So we have basically written the same, we have followed the same procedures. As you can see here, they have asked to create 2 different folders, which one of them which we have created, next one we are going to create, and then we are writing the code. So now let's create a next folder, as it is mentioned in the documentation. The next folder, what they are saying is create a test folder, in which we are going to add the test file, which is a Go language file, .go file. So the Go file is going to be the file which will responsible to execute our Terratest, and basically they will it will provision the infrastructure and validate it whether it is provisioning the provisioned infrastructure is created as per the expectation or not. So for this, as we are going to write the test file, so in order to let the Go compiler know that the given file is a test file, you have to have a proper naming convention. So you need to have a file name with underscore test as in suffix. So let's say we can call it as an main underscore test dot go. That's the file. So this is the file naming convention it should have. So we need to have this particular naming convention for any of the test file which we are writing. I'll press enter and create this file. So this is my test file which we have, and this particular file will basically call this provisioner, and this provisioner will call this particular block to create the infrastructure, which is the story account in this case. Okay, now this is a very basic Go file or the Go test file which we have created. Now just to give you some background or some information about the Go language or how it works. So I may be wrong, but in my understanding, any Go file, in order to make it work, it needs to have at least one package defined. So any Go file, it is going to be treated as a package. So you need to have a namespace defined, which instead of namespace, they are calling it as a package. So in the .NET language, you define the using statement, which defines your packages or the namespace. Here, similarly, here you use the keyword package. So package defines this particular file as the overall deployable package. So when somebody would like to use it, they will use it by referring it as the package name which you have given. So first of all, we are going to define the name of the package, which you can give any name. So we are going to call it as a main package here, and then we can write out unit test case method. So rule number 2 here to write the unit test case method is, as we are using the test case method, and this particular file could have many methods, right? In general, it could have many sub method or methods. So to identify the Go compiler, which method is of type test, then you need to have a prefix to a method name, prefix as in test, and then Terraform, and then Terraform is the basically we are letting the Terragrunt know that this is the method which is being decorated as the test method, and this is what we want to test. And then later on we can call it anything, story account. Okay, so that's the method name. Obviously we need to have a function keyword, so the function is the keyword to define the method name, and then the prefix, which is this prefix which we need to use. Now this particular method should come from the star.testing.t. So that's the basically, so any test method which we would like to utilize or which we would like to write and utilize their built-in test features, it has to import the testing package. So testing is the package which we would like to import it here as the first argument, which is a pointer type of argument. So now as I may use the keyword called import the package, it means that we need to import this particular package. Sometimes Visual Studio Code automatically imports the package intelligently. If not, then you need to use the keyword import, and that's the import keyword which you can use, and that's the package name, basically testing, that will help you to import this particular package which we have. Okay, and now as soon as I have used the keyword import, as you can see, it's trying to save this file, and so our file is ready now. I'll move back here. Now these are the code block which we need. So this is the Terragrunt or the Terratest package, which is responsible for executing the Terraform commands like Terraform init, apply, and destroy. And it also has some built-in method which basically retrieves the output and so on, whatever Terraform functionality we need. So the Terragrunt or the Terratest has the package which we would need to basically use this particular code, so we need to import those packages as well. So what are those packages? These are the one which is been mentioned here. So as you can see, this particular package is been given here in the Terragrunt website on the GitHub. So it is publicly available. You can go to the website on the GitHub and then search for this, and you'll find the package definition. Next, we are using some assert. The asserts, we know that in any test writing approach, we would like to assert our input and output just to match the expected versus the actual facts. So to validate the fact, we need to have the assert available, so that with the help of assert, basically we'll say that whether the particular test is being succeeded or failed. So that's the reason we are using, or we are importing another package called the assert, which is part of stretch SHR or the part of testify. So that's the reason we have imported these three packages. So subsequently, if you are using any other library in your Terraform code or in your Go language code, so in .NET you use the using block. So similarly here you use the import block to import some third-party packages. Okay, with that our code is ready. Now our test method is ready. Now let's try to understand this Terratest block or the Terratest method which are available with Terraform. So as the clear-cut description is given by the method itself, it says that given by these statement itself. First of all, these are the Terraform statements. So a statement, it means it says that what are the default values or the parameters which we would like to pass while calling the each and individual commands or the Terraform commands. For example, when you run the Terraform init command, so you might want to run the Terraform init with the remote backend configuration, or when you run the plan command, you might want to run the plan command with the some variables or the variable files, or we want to store the output with -outcome command, or you may want to run the Terraform command with the auto approve option. So this is where you define all those configurations. So where exactly is the location of your directory which you want to test. So in this case, we are on the test file here on this particular location, and we would like to test it, the provision, and provision will call this particular module. So we need to define the directory of provision. So if I use my IntelliPath, so that will tell me where to go. So that's the folder I would like to target it. Okay, next you need to define the methods which you want to call to run your Terragrunt or Terratest. So here, this is the very first method, terraform.destroy, and with that option we would like to use destroy on which directory. This apply the destroy on with this particular configuration. Similarly, Terraform init and Terraform plan will be applied on here, and then you would basically use the output method. So there are many methods available with the Terratest package which you can use. So for example, this particular method which is returning output of literal type, which will return the string kind of output. Again, it will use the same Terraform configuration output. Okay, and then finally you are basically asserting the result of actual versus expected. Okay, simply it is very simple to understand here so far. Now we want to test this Go file. So first of all, we need to initialize this Go file as the module. So for this, we are going to use the go mod command. So go mod initialize, and then we need to provide the name of the module. Typically, it's recommended that you provide the module name as your website name, and then your account name, which is, let's say, the learner, and then you will provide the name of your module, let's say Terratest, something like that, or whatever you want to call it basically. Or you can simply call the go mod, let's say call it as main, and that will also initialize the module. So I would like to call it as a go mod init and the Terratest module. So basically it will initialize it. And here it is asking to run the go mod tidy. So what will tidy command will do, it will download these dependent packages while initializing the module. At the same time, if you have seen that when I run the go mod initialization command, this is where a .go mod file is being created. So now next I'm going to run the go mod tidy command so that it downloads the dependent packages as it goes. And as you can see here, it's trying to download these 3 packages here on my machine so that it can identify the relevant package method which we are using it at the compile time, and Go compiler will know that how to basically invoke this method using these packages. So that has basically created a go.sum file. If I open this particular file, this has basically downloaded all those modules here. Okay, with that we are ready. So next thing what we need to do is we can run the go.test command, and we can specify the timeout when we would like to time out this particular module. So now if I run this command, that will basically run or try to run those command. Let's say we have got an error here because on the line number 8 we have added curly braces afterwards, whereas it has required the curly braces like this. Okay, with that, let's save the file. I'll try to run again. So as we have expected, the provider is trying to basically run all these commands here, and it has failed actually, and it's trying to it's basically retrying again based on the configuration. So it will retry a couple of times the default configuration, whatever it has been mentioned here, which we can basically change those retry configuration from this particular options field. Otherwise we'll try to retry again and again. So it has initialized the second time, it has initialized the Terraform successfully. So the Terraform initialization is done, and we know that this is targeting to the provision directory. So now if I open the provision directory while it is running, we have the .terraform directory and .scl directory. That .scl file has been created because of this initialization. So our test case is failed, which is what I was expecting, because it hasn't found the authentication token because we haven't configured our test cases to let the Terraform know that how it would like to authenticate when it is going to run the Azure provider. And actually we don't need to target the actual our Azure provider for this particular demonstration. So let me go ahead and do one thing. What I'll do, for just this round of testing, I'll comment this out. Okay, and then we will run the Terraform provider block. So I'll simply just use the same output hello world, which is what it is given here on the website, just to validate our test cases are working fine as it is expected. So let's clear the terminal, and I would like to rerun this command. So at this run, we are just targeting the execution of these 3 commands: Terraform, plan, apply, and destroy, and that will just simply return the outcome. So we are not basically testing the actual infrastructure. This is just to make sure that the test method is working fine as it is expected, and then later on we'll modify the changes such as the authentication. As you can see, this time it has run the Terraform plan command successfully. It has run the apply as well, and with that apply, it has returned the outcome as a hello world. And then after returning the output, it has run the test case and validated the test case, and then once the test case is succeeded, it has run the destroy command. So with that, the test case is completed, and this is what the result we got. So our basic test case is completed, and we can see that our go test file is been configured correctly, though we are not testing the infrastructure as it is expected. So we are just testing the output result as of now. Now, coming back to the point wherein we have specified these methods, Terraform initialization is fairly simple. It is using this options block. And here with the destroy, we are using the keyword defer. So this is really important rule here, that we should, with the destroy command, we should use the keyword defer, which tells the Terragrunt or Terratest that no matter what is the result of the test, it needs to run the Terraform destroy command regardless of result. So even though if it is failed, it has to destroy the resources just to make sure that it's going to destroy all the resources after the successful or after the execution, the test execution finishes. The reason for that is the way Terraform infrastructure or the test cases works. Basically, it is calling the module or the provisioner module, and provisioner module is calling the resource block or the module block, and it is actually provisioning the actual resources to your target infrastructure. Let's say in this case Azure subscription. So it will create the actual storage account in the Azure subscription, and then will validate that particular storage account just to make sure your storage account has the valid configuration as we have expected. And once the validation has been confirmed, we would like to destroy the storage account resource just to avoid any unnecessary cost to our clients with that unnecessary infrastructure resources which we have just created for the test cases. So it is really important to use this defer keyword. Okay. So let's configure the authentication mechanism for our Terratest. First of all, I would like to uncomment the module, because this time we would like to basically test our actual module. So I'll just uncomment this block. Okay. So here, what I've done is I've just changed the definition, and you can see that the majority of changes are here in the Terraform option. So what we are doing earlier, we were specifying the directory of our Terraform module, which we would like to run. Next, we are here specifying the parameters which we want to pass to test the infrastructure. Let's say for creating the storage account, these are the parameters which we would require. And now we are providing some of the environment variables. These are the environment variable which we would require to automate the infrastructure, to authenticate our Azure Terraform code with Azure subscription. And then this is the remote backend configuration. If you would like to configure, this is just the configuration for the terminal related configuration basically, and the rest of the methods are as is. Obviously, these are the variables values which we are passing to the module to provision the resource, in this case storage account. So we need to define those variables. So some of the variables are defined it like this. So now, if just one more point about the Go language, those who do not understand the Go, if you do not declare a variable with its type, and if you want to set the values in the Go, then you can use this $=2 sign. So what it will do, it will create a variable in Go with this name, which is of type string, because we are setting the string type of value here. If we set the numeric number or any other type, then it will automatically make sure that this variable is of type, which is the type of value which is being assigned to this variable. So that will automatically create that type of variable value here. So we have created these values, these variables here, and we are using these variables here while setting the while calling our Terraform command. So this is basically our expected infrastructure values. Like I would like to create the infrastructure storage account in this location, tier of this type, and account kind is of this type for my storage account. As I mentioned, we have specified, we need to specify some of the environment variable for our infrastructure. So we need to read those environment variables from the, we need to set those environment variable here on the global variable file. So we need to create a variable called global environment variable, which will create it now. So if this is how you can create a variable. So if you have a bunch of variables, you can set those variables or group those variables using the var keyword and a small opening bracket and closing bracket, and within the opening and closing bracket you can initialize or set the values of those variables. So these are the values which we have defined. So I have a unique postfix values, which is using a package, the random package here. So obviously I need to import a random package here in my import directory, the import configuration, so that I can use the import. So what this unique method will do, it will generate a unique 6 character for my resource type, and then with that 6 character I can use that character as a unique name while creating the infrastructure, just to avoid any naming confusion or naming convention while creating the resource. So these are 3 variables, and then we have 2 more variables, the name of the resource group. I'm expecting my infrastructure to be created in a predefined resource group, so that's the resource group I'm going to use, and that's the same resource group which we have passed on here, so that let's say later on if you would like to perform some cleanup activity, we are not creating a random resource groups and not provisioning those resources in those random resource groups. So we are passing the resource group subscription ID as well. You can basically read the subscription from the environment variable as well. We are basically reading with the help of OS operating system package. So there is the golang package OS, which can read the values from the operating system, such as the environment variable values. So we are using the get environment value and then passing the name of the environment variables, or the environment variable which we have set in the windows. So that will basically read the value from the environment variables. Obviously it means that we need to set those environment variable before we run the command. And again, once we read the value, we are setting those values here in the global configuration, so that the Terraform will authenticate with the help of this global configuration which we are passing here. Okay, so this is our configuration is ready now, and as you can see, we have configured in a dedicated separate method here. So, and this is not decorated as a test method, if you see the difference. So here we have a prefix as the test Terraform, and this is just a normal method. We are calling this particular method here at the second line, which says that this is going to be initialization is required first of all, and then perform the rest of the operation. T.parallel is let's say if you have multiple test methods in this Go file, then, and if you want to run those methods parallelly, then you can use the T.parallel method. Otherwise there is no point of using this particular method as is. Okay, rest of them will remain same. So with that, let's look at the Azure CLI command to create a service principal. So you can use this create sp create rback command and then create a service principal, and then assign that particular service principal to the subscription level or the resource group level, whichever you prefer. And once you have the service principal and subscription level ready, what you can it will give the outcome as something like this, and this is the outcome which will have the client ID and secret and the tenant ID. Once you have this client ID and secret and tenant, you can use this $env colon, and then you can set the value of these value of the environment in the command line. So I'll open the command line here. Let me clean up this, and I'll set all those environment variables. So with that, it will basically run these. It will read the OS package and read the environment variable values. So let me use a package called OS, and here with the storage account, I would like to use the method called toLower, because we know that the storage account needs to have the lowercase character only, and this random can generate the uppercase as well. Okay, so with that, I'm using this string package, so I'd like to import the string as well. Okay, now it should be ready, and we'll test again. Okay, so what I have added two more variables to my story account module because I would like to set the prefix and the separator. So prefix is going to be st, and then this, so that the story account name is going to be st, and then followed by the unique postfix which has been created from here, and then I'll use the separator as a blank. Okay, so let's run our test cases now. And again, I would like to run the same test command, which is go test timeout 60 minutes. It has failed. The reason for that is because we haven't specified or used the package random here. Okay, it's my bad. There is no package called random. It has to be something like this, random. So it is in the terragrunt.io Terratest, and it's part of the random module itself. So I'm going to include that as the package. I'll run again. This is just to let you know how basically you can figure out the errors and fix the errors while writing the code. I would have let's copy and paste the code and then simply run it with the success, but just I wanted to make sure that we have failed a couple of times so that we learn how do we fix those failed scenarios. I hope it makes sense. So this time, basically, it's at least compilation point of view, it has compiled successfully. Now it's trying to initialize the Terraform with the Terraform initialization. Initialization is completed. Now it's trying to run the Terraform plan, and then it will run the apply. Okay, so we have got an error in our Terraform code, which you can see here. It says resource name prefix p not been declared. So let's see if it is declared or not. Okay, it should be unique postfix. That's why. I'll clear the terminal, run it again. So this time it has compiled successfully. Now it's trying to run the Terraform initialization. Initialization is also completed. It will run the Terraform plan and apply with the parameters which we have passed. So if you look at these lines, it's passing the same parameters with this unique character. And our story account execution is started successfully. It means the authentication part is also completed. So we have got the output, and while running our test cases, it has failed, and still it's running the destroy command as because we have used the deferred keyword, and deferred will tell that even the test cases is failed, it's supposed to destroy the infrastructure, and that's what it is going to do. So this is just to show you that how do you fail the test case and then make sure that the infrastructure is basically destroying it, the resources. And as you can see, these minus signs, which shows that it's going to run the destroy command. It will destroy this particular resource from the infrastructure point of view. So if we try to read out the error, it says on the output line number 19, it says that the underline output go hello world is not found because we do not have the output written from our Terraform code such called as in hello world. So I have knowingly basically put this code, this assert, that this particular block, because it's trying to read this particular output and we don't have such output available in our Terraform code. That's why it is failing. Even though if it might have written something values, then this would have failed here in the equals part. So after the test execution, this is what the result we are getting. The test has been completed, resource has been destroyed, and the test result says that it's failed. Okay, so we know that it's going to fail. So let's use so I have added a storage account ID resource so that we can validate our resource type, and the same resource ID output I'll return it, capture it here, and we'll say that for now I'll just comment this out. Now, most of the people write the assertion based on the output values. So, for example, in our case, we are getting the output as the story account resource ID or the story account ID, and we could have write the assertions like, let's say, story account ID equals to or contains or whatever assertion methods are available which we can utilize here, and that will basically pass our test cases. But that's not the real test cases, because the objective here is not only just to test your Terraform code, but it is just to test your infrastructure or the desired infrastructure which we have provisioned. So it's actually a integrated test cases which we would like to perform here. And that's the reason when you perform the assertion, you need to make sure that you are performing the assertion from the actual resource which has been configured the target infrastructure. So what I mean here is we need to get the actual values from the resource which we have provisioned with this Terraform run, and then from those returned values or output we should compare the assertion or perform our assertion operations, rather than just performing the assertion based on the output result which we are getting it. So in my opinion, performing the assertion from the output result is just going to validate your Terraform code, but not to the actual infrastructure which we have provisioned. So remember that when you perform the assertion, you have to perform the assertion from the actual resource. One reason, before we go ahead and learn how do you get the value of the actual resource here in the here in your test case, I would like to give you one valid reason why do you want to do that. Because it might possible, let's say if you are creating infrastructure such as the story account with some different name, for example, but let's say as the developer, I have manipulated your code and I'm creating output, for example, here with these output variables which I'm calling it, let's say, story account, for example. I could have write the story account like this, for example. Let's go to the story account here. So I could do something like this, and with that I can add the name as the story account name. So in actual fact, whether your story account has been created with different name or actual name, if I return this dummy value, and now with that dummy value, if you are comparing the contains as the name of the story account within this resource ID, so even though you are creating something else, for example, let's say if you are creating it a story account with this, I have added 01 here. I'm creating a storage account with 01, and in your production or in your infrastructure, you are always creating a appending suffix 01 with your storage account. But you are basically telling lie, or you are falsifying your infrastructure, your test cases, that you are creating a infrastructure or the story account with the name, because here I have just modified as the not to developer, I have just modified the basically outcome, and still your test cases are going to succeed, even though your infrastructure is actually returning something else, which in this case it should fail, isn't it? That's the whole objective of the infrastructure test cases. So that's why I said you should always perform the validation or the assertion from the actual live resource. So what do I mean by that is, now as at this stage, which is the state it will run Terraform init and apply, we need to make sure that it's going to we need to make sure that after apply we read the actual resource from the Azure. And in the Azure we know that we have so many REST API functionality available which we can utilize to read the value as the REST API outcome, and then from that REST API we can validate whether the resource has been provisioned successfully or what is the actual state of that particular resource. So just to give you an idea about the REST API, so if I search the Azure Management REST API, so that's the management REST API I'm talking about. With this particular URL, you do have all the REST API for the different type of resources. So whether it is app service or any other type of resource, storage, networking, databases, everything, all the REST APIs are basically available here. So for example, in case of storage account, I would like to go to the storage resource provider, and then within the references, I do have this storage account. And if I look at the overview section of the storage account, get properties basically. So that's the management API which we would like to test it. And if I simply pass the information like subscription ID and then resource group name and the account, basically I can get the information about my storage account, such as what is the kind of storage account, location, what are the different properties available with this storage account, network rule configuration, primary endpoints, and everything about this storage account. And based on this information, basically I can validate my storage account with the help of assertion. So now this is what we would like to do it. Obviously this API, get API, would require the authentication token. So with the Golang packages, we do have certain number of packages available which supports the Azure SDK. So what we are going to do now is we are going to import those SDK packages to our source code, and then we'll authenticate or generate a bearer token, and then call the method get resource by resource ID. I'll show you. So these are the two packages, Azure Identity and the Azure RM resources. So these are the packages which is available inside the GitHub within the Azure SDK for Go repository, which we need to use. So with this package which we have imported, I'm going to create a new method which we are calling it as a get resource from the REST API, and it will return the output as the ARM resource type, which is the response structure. And here we are going to use the context, which is a default context, and then within the with the help of identity package, we'll initialize the default credential. So this default credential basically uses the same environment variables which we have set to authenticate our Terraform code. Basically, this is the credential it will generate, which we can use to generate the token. And with that credential, I am going to use the Azure RM resource type, and this is the resource type which we are going to basically use to get the value of we can initialize as a client, resource manager client, and within the resource manager client we are going to use a method get by ID, which will have a value as the resource ID, and this resource ID will basically which will pass. Obviously this will require API version. So API version is this particular version which we have. So we have defined this API version as a constant because Microsoft keep on changing this particular version, so we need to make sure that we are using the appropriate version which we would like to use for the resource type which we are using. So the get by ID method will basically use this particular method, and this is the resource ID up to this, and this is your API ID. So three parameter. This is the base parameter, base URI. This is the URI of resource ID, and this is your API version, and that's what we are passing to. So base URI is already implemented inside this particular method, and then you are passing the context, which is the current context, and the resource ID and API version for this particular example. Okay, here we are using some log. We are writing it down, some of the logs to make sure that what's going on in case if you would like to troubleshoot, and that's the reason we would like to add the import the logs. As you can see, you can use this IntelliSense from the Visual Studio Code to import the packages. You need to use the context package as well. Let's see if we have context. Yeah, import this package as well. which we did, I guess. I'll add the format package as well because I'm using the format functionality. So finally, this is the final list of all the packages which we are using. And what we would like to do is we would like to call this particular method here right after we get the value, which is the story account resource ID type, and this will return the result. So we'll call it as the response equals to error, and then we'll define it like this. So this is going to be our response. I would like to reuse the error in case of there are any errors. So I'll say that response failure. Okay, that will log the error related to response. Now once we have a response available, we would like to that will return the response in this particular format, and basically retrieving the response from this format. This response structure type has its own properties. For example, it has certain number of properties called name, SKUs, kind, and then dot property as a structure, which is a complex type. So getting the detail out of that complex structure is sometime harder. So what I believe is it's much more simple to define your own classes for your to get the output. And then basically what we can do here is let's say first of all define our own class for this story account. So in the class or the structure in this story account, for the story account, so the way you define the structure is based upon the output which we have it here available as a sample output available here for the story account. So we know that in the response type, which is, let's say the response is this, so I'll call it as the base response .go. I have created a new Go file, and I'll add the Go file in the same package because I would like to use the same package what I have it here for my main underscore test file. And here we are going to use the class and define our class. You can give any name to this based on this particular Go file. Just given this name, and here is the type. This is how you define the type. So type as the response base. I have given the name. You can give it response base as a name. You can give any name, and then you need to define the different properties. For example, this is the ID, and then we have kind, and then we have name, and then we have properties. Okay, so we have, so in the JSON we would have kind, which we would like to add here, which is again going to be a string type. And then from JSON to here we would like to map the small case letter kind. So it's going to be kind as in small k, and it might possible I would like to map this as the, so in JSON it will look like something like this. And then we have a properties. Again, it is a complex type, so we need to define another complex type which is of type property. So depending upon which property you want to use, you can use those, you can define those property types here. So for example, let's say this is my property type which I would like to define as, so based on the structure of the JSON, I managed to create my base response, which is for the storage account, and base response would have my resource ID, location, name, kind, and property. And the property itself has the provision state, which will say whether the provisioning of the resources has been succeeded or not. This is really important that we know the execution of the resource provisioning is succeeded or not, and we would like to validate that particular status. So, and then we have other properties of the story account, such as the SKU, primary endpoints, HNS available, and the SKU type again has some properties like name and tier, and then you have the primary endpoints such as the blob, file, queue. That's the structure you should basically you can define it looking at the options available here. Okay, so our base response type is ready now. We have our API is ready, which will return the response in a this format, which is of response type. Now, what we want to do is we want to convert this type into serialize into JSON and then deserialize into the object which we have created. So that's my method type which I'll be using, and here with this method response. So we have created a deserialize method, so which is taking a response type which has been written from this REST API, and with this response we are basically converting it into a JSON using the JSON Marshall function. So that will convert the JSON into a JSON, and then with that JSON basically we will use unmarshal into the object type, which is the type of response base which we have just now created, which is mentioned here in this particular Go file. And this result is something what we are returning it here. Okay, now with that we have our actual response ready in the format which we want, in the object type which we want. Closing state which is succeeded, for example. So like this you can have different assertions. For example, here I have the story account resource ID match, so I'm validating the actual response dot resource ID, which is response base dot resource ID, and with the result which we have written from the story account ID, resource ID which we are returning it from the output. Then I'm validating the next property, which is the story account kind, which is from the actual response dot kind property, and this is the kind which we have provided while creating the storage account. So if you look at the top here, we are passing the kind as the storage account kind. So we just want to make sure that the storage account is created with the same kind, same property. Next, we would like to validate the provisioning state of the storage account. So we need to make sure that the state is succeeded. It means the storage account resource type is successfully created. So that's the reason we are using the actual response dot property dot provision, because that's where we know that it's going to be available. Provision state dot the like response base property and then provisioning state. Okay. Next, we are validating the SKU account tier. Account tier is again which is the information which we have passed while creating this storage account, whether it is storage account type, account v2 or v1 type. So that's the property which will be available in the SKU tier. And all of this information you can get it here on the Microsoft documentation, and based on that you can create your object type like we did it here. And now if I run the test case, it should basically get the response, run this assertion, and it should show the result to me. Let's see if it works. Okay, so it has run the test case, but somehow it's failed because in our module we have, I think we have misconfigured our Terraform module. So I'll just go to the Terraform module, and this is what the mistake which we left out. And that's one of the good thing, right? If somebody is trying to validate or manipulate your changes, then at least you have your test cases which are validating that no, you have done something wrong here. So that needs to be rectified. Okay, so that's good that we have got the validation here. I'll rerun the test again. Okay, so our test cases is completed and we can see that we have 3 past test cases and there is a failed test case which is about the SKU account here. So it seems like the account here which we are validating is not correct. So if you go at the top about the error, you can get the information that this is the expected. So expected was the standard and the actual which we have received as the blank. So we need to, it seems like the actual which is our object type, the SKU object type, which holds the value, it doesn't hold the correct value. So the deserialization is not mapping to the correct property. That's what the problem it seems like. Okay, next we and now these are all the JSON values which we are basically logging it down here. So this, if you refer this particular JSON value of this toy account, we have got, I can just simply copy here just to troubleshoot, just to let you know how do I troubleshoot all these things. So what I can do is I can open the JSON lint here and then I can just arrange this output JSON in a proper format like this. And here in the property, we have SKU and then SKU is of type name and standard. So if we go up, the SKU is not part of the property. SKU is outside of the property. It's part of the main response type. And whereas the here on our base response, we have added the SKU as the part of the property. That could be problem. So if I add it here, that should basically resolve the issue, because as our JSON says that this SKU tag and type should be at the same level. So where we have specified our type and SKU, that's where we should be specifying the SKU as well, and that will basically resolve the issue. So now if in the next run, if I run, all my 4 test cases will pass. So this is how basically you can automate the infrastructure and run your test cases if you want. So we have set up a fundamental or the base structure for our test cases. Now going forward, for any new resource type, if you would like to test the or automate the or write the test cases, so only 3 things you need to change. First one is you need to change the input parameters or the list of parameters which you would like to pass to your resource type. Okay, next thing you need to change is the base response type which we have created. So in some of these properties like resource name, location will remain same, but some of the specific property related to the specific resource type, such as the primary endpoint, like vnet resource or the keyword resource type, would not have this particular property. So you make sure, depending upon this JSON or this particular JSON or resource type, you JSON outcome, you prepare your base response type. Once you have your base response type, which is the second thing, you just need to change your assert. So that's the only 3 thing you need to change, and your test cases are ready. You can deploy the changes. You can test your source code with these kind of a test cases. Remember, when I'm creating this base response, I'm only including those property which I would like to assert. I am not including a lot of all the properties which comes with this resource type. So in this particular scenario, I can remove this primary endpoint property because I'm not validating or I'm not asserting this particular property. But if you would like to assert, then this is how you decorate your properties or the complex response type in the JSON, in the golang basically. Okay, apart from this, I do not see any other changes which you might require to do. So you can simply just copy this and change 3 blocks. and your test cases will work fine. This is really easy and simple, and you don't have to rely anything anywhere. I'm using two constant here. Constant number one, the API version. It is the version which we have to pass as we are calling get by ID property, and then we have the provision state, because we would like to make sure that the state is succeeded all the time. Okay, I have shared the same implementation here on my Medium blog, so which you can find it here on this particular link. I'm sharing the link on the description, so you can find the entire detail which we have explained it here. You'll find the same detail along with the code here in this particular blog, and I'm also sharing the link to the GitHub repository, which where we have put all our code. So you can find the code, and if you want, you can download the entire code from this. In this blog, I'm sharing it with the another resource type example, which is of type virtual network. So that you have the different, so that you have the variety of test scenarios which we have covered, both video and the blog. So feel free to explore this particular blog and find the code here if you prefer blog instead of videos. With that, we are going to conclude our session. I hope you have found this useful. If it is, please do not forget to subscribe to the channel if you haven't already, and share your thumbs up with this particular video and the blog as well. Thanks for watching it again. See you in the next video. Thanks for watching it again. See you in the next video with another interesting topic.